Hello and welcome to this talk, Reactive versus Blocking with Helidon Níma. It is really a great honor and pleasure to be here with you today. As I work for Oracle, I really need to show you this slide. That means that every business decision you actually take is a subject to change. If you try to do any of your project based on the information I'm going to give you today, just check once again if there are any changes. So, it's nice to meet you. My name is Dmitry Aleksandrov. As I say, I work for Oracle and I'm working on Project Helidon, and it's really cool to talk about the project that you're working on. So if you have any questions after today's talk, there will be a Q&A session, or if you want to actually make a broader discussion, just write me an email and tweet me. I usually try to answer as soon as possible. And I would like to send special greetings from our Bulgarian Java user group, as I'm now located in Sofia. Many greetings to you from all of our community to your wonderful community. Okay, let us jump into the presentation actually. So in this presentation, I'm going to talk about task definitions and how it's better to do them. So, and what is the most typical task definition for today's development is that we need to create microservice. Yes, many people will say that, microservices are not the best solution, but it turned out this microservice architecture is pretty much solving a lot of the problems that our projects have right now, especially with scalability, especially with fault tolerance, etc., etc. So yes, microservices actually are not as bad as many people say. So actually we need to create a microservice. So how can we do this? I'm mostly sure that most of you will just take Spring Boot and create, with few annotations, a class, well, few just annotated, and with a lot of magic happening inside, it will start and actually do the stuff we need. It is exactly this way. I mean, so it's a lot of magic there, and a lot of work has been done by this awesome guys who are doing Spring Boot. There is one little but, I usually say. It is not as much standard. It means that if you write your code in long terms and you suddenly, well, you stop to be supported, or the support may become too much expensive, or something happens, or the architecture changed dramatically, well, you just have to rewrite everything. And actually, for those cases, as I say, it's not standard. So we can do it a little bit different way. So this way is called microprofile, which is exactly a standard way of writing microservices today, as it is based on an open source community specification for actually enterprise Java microservices. Yes, it's currently hosted at Eclipse Foundation. That means that there's it's non-commercial foundation with many participants. And as I say, many participants, there are really a lot of them who are working on this specification set, which includes Oracle, IBM, Red Hat, Atomic Tribe, and even Microsoft are there, and they're quite active, by the way. So it's really nice. And once again, it is not a product, it's a set of specifications which other vendors, actually participants in this community, have to implement. That means that the community works on documents and specification which describe how and when you should do your stuff with microservices. And actually the vendors themselves implement those specifications, maybe with some exclusive features. But the idea is that all the code that you have, which is written inside a microprofile, can be easily ported between different implementation. And it's released really, I would say, often. So we have 4 releases per year. And you can find more information about microprofile.io. Actually, as I say, currently in microprofile there are 13 main specifications, and many people usually say that, okay, this is plain old Java EE, which is very old and very, I would say, slow. Actually not. Although there are overlapping specification, this special set of specifications is really designed to work on in the microservices world. And microservices world, in terms of computer science, is something that is a highly distributed system. And for example, what is typical for a highly distributed computer system is that each of its components can fail unpredictably and immediately. So that's why there are specifications specially dealing with that. Like, for example, health checks. We can check if our service is actually ready to serve us a request. if it's not, for example, there should be a fault tolerance. There is a specification for that. So that means that whenever some failure occurs, you have a graceful way to handle it. Since one business call can actually be done via many service calls, it can be traced. For example, there's tracing specifications for calling other services. You have REST client who actually talk to other microservices. If you need to describe your API or even to generate a client out of it, there's an open API specification for that. And even the configuration itself is portable. So that means that if you configure something in one server by one vendor, in terms of same version of microprofile, even the configuration can be easily ported. So as I see, this is one of the main ideas of microprofile. So it's a standard way of writing microservices with great idea of portability of your code between different vendors. But actually, have you ever thought about performance here? And this is going to be the focus of this talk, but very fundamental focus of this talk. So I'm going to take not about how to gain more and more requests per second, but actually we'll think in more general way how to achieve better performance, really in a fundamental way. And we can take the example of Helidon, actually, which I'm part of a wonderful team I'm working on. And I believe it's a good example because I will show you absolutely different aspects of using Helidon in applications for creating microservices. This is the basic architecture of Helidon, so it's very easy. So we have netty underneath, so we are unblocking by nature, and we are reactive by nature. And actually, to live in this microservices world, we need not just to send information between the services in a plain way. We need exactly a correct behavior of our microservices as they work together. So as I told you, there are those specifications I showed you, and to implement those specifications, there's a layer above, which is called Helidon Reactive. This is a reactive implementation of specifications for tolerance, for metrics, health check, and so on and so on. So it's pure Java. I will come to it a little bit later. And on top of it, actually, we have this Helidon microprofile, which exactly implements the microprofile specification. I'll talk about it here. So technically, Helidon now is like two products in one. That means that you can choose your way of writing code. If you choose MP, it will be a declarative style, a very inspired by Spring Boot. It's Spring Boot-ish style. It's based on microprofile, so the code is portable itself. It's quite fast, small footprint, etc., etc. And the magic is done with annotation. So just annotate your class, and suddenly something happens. It becomes a microservice. The other way is to write your code in pure Java in pure reactive way, which is non-blocking. And this is the way you choose this Helidon SE. So it's as you see, you write your code in pure Java, and there's only one annotation, which is override. There's absolutely no magic like in CDI with inversion of control, etc., etc., and it's incredibly fast. So actually, by having two of these projects, you are a little bit like faced to a choice. Should it be a portable way of doing stuff but slower, or should it be extremely fast way of doing stuff but without portability? Let us explore the options. So we'll start with Helidon MP. So as I told you, there are many specifications that we implement, but with Helidon MP, you actually have more of them. So it's not only microprofile specification, but there are also Jakarta specifications there, which we implement with work with WebSocket, with persistence, transaction, etc., etc. There are other specifications which are on the cover of under umbrella of microprofile, but they're not part of this 13 I showed you previously. And these are the microprofile GraphQL, LRA, reactive messaging, and stream operators. They are also included in MP. That means that you could write your code and achieve really good performance, I would say, really awesome performance in three different ways. So you can just create jar files, you can create native images, because we have full support of GraalVM native image, or you can also have the something in the middle. It's JLink image. JLink image means that you create your custom JVM and you throw away all the stuff you need. And it is really interesting because uh, Helidon itself by its nature is modular. That means we are, by default we are modular. So we're using this modular Java modularity, and that's why as we actually create our custom image, the startup times and disk usage and memory usage are better. And I just want to say that we are best in class because we provide GraalVM native image support even with full CDI inside of native image. So that makes us quite unique. That means that you can create full CDI applications with Weld in GraalVM native image. Yes, and now with version 3.x, it's totally Jakartified. So we moved to Jakarta namespace, and we actually require Java 17. So that means we're really on the edge of what the technology brings us today, and what is the newest standard for creating that. Actually, how would you ever start with Helidon MP? Well, we're quite happy that with the release of 3, we have this generator, this project generator, which is we have project starter, which is available directly on our page. So I will just immediately go there with Helidon.io. And we will create a project together. So we'll just click starter, we will select the MP flavor. We will create a quick start right now, but actually you have more options. You can choose media support. You can customize your project as much as you can. For example, if I choose custom and click next, it will ask what is the JSON support library. Should we need fault tolerance and CORS? What will be the packaging options? Should we need Docker image, Kubernetes image? Verrazano, what would be the observability features, Mailhead, and for example, if you want stuff to database, you can also set it up, like which database with which JPA implementation with which connection pool. So it's really quite impressive, and I would say not very typical project generator, because usually you just open, there is a bunch of libraries, and you just click here. We made it with a wizard style. So we just create an image, download the file. So, and I just unzip it, and I open it my favorite IntelliJ IDEA. So it's opened here. Just give me a second. Yes, and what we have actually here. So it's the source code, Java, and there's a simple greeting actually application. As you see, it is following. Hello. Oh, good. It's following the style of a typical application with Spring Boot-ish style. So we have annotations like path. We inject some greeting resources. We say that for this endpoint, we will need to work on GET request responses, timed, etc., etc. So it works. It's very easy. So we just actually build it. Our terminal, Maven, clean package. We don't need the test right now. Yeah. We just run it with Java minus jar target my project, I guess. Yes, my project. And quite immediately we receive our local host is up and running, and we can create, for example, not create but greet us with hello world. The same you can do. So you see, it's cloud native ready. That means that we know that we work with clouds, and that's why out of the box you have health checks to see if everything is okay, and you have metrics information just to check that really it works as expected, and you can monitor and trace. So it just has it out of the box. So with this generator you can easily play with Helidon. It can be like a foundation for you to start your application. So once again, this is the micro profile way of doing things. That means it provides you a standard way of doing applications and portable applications. By the way, just to let you know, they also have CLI, which actually can do the same for you, and even more than that. I will show you it in our other example. So, okay, once again, this is fine if you focus your portability and you have long-term project which has to have good support for like average count of users. But what if you need performance, like a lot of performance? Actually, for this, we will use this Helidon Reactive, which actually follows the main, currently the main paradigm for achieving performance is a non-blocking way of writing stuff, reactive way of stuff. And, we personally call it the danger zone because actually the same specifications as you saw in Helidon MP, they are all implemented in reactive way in Helidon SE. So it has not only like config security health checks and so on, it has even more. I will talk about them like Helidon web client and DB client. They're also made reactive for you. But once again, here as we throw away all the standards compatibility with CDI, with modules there, etc., we will receive something which has a very, very small memory footprint, and it will really gain a lot of performance. And as it's modular by default, you will see that the same way as previously, you can achieve really small numbers. You can create your custom JVMs and you can build everything in native image. So really great performance. And actually, how we did it, just to show you that what was the main intention. So as we know that it will be working very critical points in our systems because it was mainly created as an internal project for Oracle, but the performance here was the most significant and important part. And we wanted to have as less dependencies as possible from outside world, so that's why we actually created our own Helidon reactive engine. So that means that you don't have any other dependencies to other projects. This is achieved by only our code. So we have our own set of reactive operators. These operators are based on Java 10 Flow API that we have. So that means that we did not invent something new. We just reused something which was already there in Java. And for stream processing operators, we have two of them, which is multi and single. So multi, if you have multiple values, you can actually create this list, then map some information on, then for each, well, for example, add and get something, so to create a sum of these operations. So that means that you can process a stream of things that happen. If you have just one result, you will use single. As easy as that. So asynchronously, you can chain many reactions of asynchronous processing of the result. And as I said, you can chain many of them. So we have quite a decent set of Helidon reactive engine operators. And they are, well, I would say enough for you to do completely nicely organized reactive programming. So you can easily just create several stages. You can have a composition of stages. Like for example, first you publish something, then you process something, and then you actually compose this one to happen right after another with quite a regular set of operations. And as a result, actually, we see that Helidon Reactive Engine is quite decent in performance. As you see, even with our competitors, we have sometimes twice as bad in terms of performance. And as a result of that, now as we have engine done, so we created our own pure reactive Helidon web server. Reactive, that means that you just send something and it's like fire and forget. It means that the processing will happen completely asynchronously. Yes, and it's very easy to create, so we use a lot of builder patterns, so quite straightforward. So let us actually create one small project just to compare between these two flavors. And I will do this using the Helidon application in it. So it is available on our website. You can download it. It's written in pure Java and it's compiled to native image to 3 different operating systems. It's just easily installable. And here you create actually a new project. So we will create projects with Helidon MP flavor. It will be again the quick start. And we will just say, do we need a development loop? Right now we don't need it. And as easy as that. So it has generated a project for us. And let us open it in our favorite IDE. In our case, is once again the IDE. So what you have here is that you don't have so much magic. And if you take a look at the code, it will be pure Java code with main method and main class. And you see, you start creating everything asynchronously. For example, the server, just build the server, take the configuration from file, add some media support, for example, and as you start the server, it will return you not the web server object, but a single with it. That means it will say that it's a wrapper over it saying, okay, here is the object. Whenever it gets initialized, you can get it or you can chain a reaction to it, and so on and so on. So that means that whenever server is ready, we say that except whenever it's ready, just say server is up, and if there is an exception, there's a graceful way to handle it, saying like, for example, if there's exception, exceptionally accept that something has gone wrong and we cannot continue. The main consequence again is that you have server, and for this server you have routing. Routing means association of endpoints and functions or services that work for them. So if we go to this simple service, it has only to implement one actually interface service and just two main methods like in this case it's going to be update to overwrite the update method. That means that it will associate the rules, like which endpoint to which function should go, and the functions themselves are quite easy. So it just gets server request and server response. So you get a request, do something, create a response, and send it. That's it, and it's done completely asynchronous. What is actually amazing about that is that you just run it as your main class. So you don't need to create some magic, etc., for that. It will just compile and run as a usual Java application, and as a result, it should be extremely fast. Really, really fast. And if we try it again, we'll get absolutely the same result. We can also check health. Yes, you see, it returns us the health of the service, and for example, the metrics. Yes, also in Prometheus format. So that means that with fewer code, with main methods, without any magic, we have created a fully functional or reactive service. And this reactive service works, as you see, as expected. So we can just turn it off. Great. So, and here we use the CLI, so I highly recommend to have one. It has more than just server capability. As micro-profile reactive messaging, it adopts it in reactive way. So that means that you have like a wrapper, like an interface for every message that can be sent to underlying broker, should be Kafka, ActiveMQ, or JMS. It's in a standard way. Then it will go and be received by the other party, and it's done in a reactive way. So that means that we can create like really big flows of events, like messaging. We can publish the events, then process them, and then we subscribe to all the changes. And these things, like all this conjunction, is called channel. So we have a channel with like some input, processing, and output. Quite an easy concept, but it's really powerful. And as I said, once reactive, you always have to be reactive. What does that mean? That means that even with your database, you have to work reactively. That means that you can't create code which is blocking somewhere and somewhere reactive. It always have to be reactive. Otherwise, you will just stuck in some situation and all of your threads will be blocked, for example, with some waiting. So there's no reactive there. So we have created our own DB client, so now you can talk to any JDBC and NoSQL database in a reactive way, although they are blocking, but they will be run in a separate executor, and we will care about that. And well, they will be asynchronous for you. Quite easy. And the same is for web clients. We have our own reactive web client, actually reads responses from other services. So because of the network latency or whatever, it's also tolerant, and it's also made reactive. But there's one small but in all of that stuff. As I told you, for performance, we really need reactive because it's non-blocking for utilizing the thread as much as possible. But learning to code reactive is hard. At least for me, many of you have tried it. So it has very steep learning curve. So you really have to work a lot to gain efficiency in that. So the stock traces, for example, debugging reactive code is really a pain, although IntelliJ has done tremendous work to make us good reactive debuggers, but still reactive is hard to debug. Most often you have only one task in parallel, and you just don't use the resources as much as you can. And of course, if you have too much callbacks, you just end up with callback hell. It's hard to code. It is extremely hard to debug, but it's very fast. So actually, what is interesting? So Helidon provides you two ways of doing stuff: more portable, more standard but slower, or extremely fast but hard to write. And it's not about Helidon; it's about the paradigm itself. Any other implementation reactive you should take, it will be hard to learn it because it changed your brain so well hard. So, but what if reactive is actually too hard? And here we are witnessing a big change happening in Java ecosystem. And it's provided by Project Loom, which introduces something called virtual threads. So yes, JEP is already there. JEP Java Enhancement Proposal is already there after years of development. And what is the main idea actually? So in Project Loom, which was previously a research project, especially based on virtual threads and the idea, they have created virtual threads which are by API absolutely the same as normal threads, because Java from the very beginning supports parallel programming, but it's reusing the operating OS threads. And to do this, they are very hard as a resource. They are very, I would say, expensive as a resource. So for every thread, you have to have some thread pools. You have to create some overhead with meta information, etc., etc. So I would say that more than 400 virtual threads, it will be extremely hard to run even on modern hardware, because otherwise they will just wait for each other all the time. So they created those virtual threads, which are technically a lightweight threads. They previously called them fibers, with the main idea that they look absolutely the same as normal threads. They do the same work for you, but it lets virtual machine identify if this thread blocked or it's not blocked. If it's blocked, it will unmount it automatically for you and put some other thread with some work to do on this thread, carrier thread, which is the OS thread, just to utilize the resources as much as possible. So it's based on fork join pool carrier underneath, with some implementation of continuations. So that means that the state between the virtual thread is kept in continuations, and whenever we have to restore a virtual thread, we'll just start from this continuation process. So that means that currently there are really, now you can have millions of threads where they come to you at a really cheap price. So they don't block real threads. So virtual machine takes care about them blocking or not blocking them. And they are threads by API. Currently, they are available as a preview feature in JDK 19+. That means that you can already start doing this. And one of the main differences is that now you have a different executor, so virtual thread executor, and you can check if the thread is virtual or not. So just to identify, is it maybe, is it correctly set up? So, and by having this, as you know, Helidon is developed in Oracle team, so we are in very tight cooperation with the JVM guys. And interestingly, that Helidon MP currently for years supports working with virtual threads. That means that he can change the executor of Netty, which is underneath him, to virtual thread executor, and it will be easily done with just enabling one option. So executor service virtual threads enable, and that's it. It will route and create all the threads virtually for you. I can enforce that as well with another option. So what is interesting as a result that I will show you a little bit later in the real code is that currently you don't have to rewrite everything. It's so easy. So we just write the blocking code as you used to. You write it like a recipe, what to do next, not with these strange, I would say, hard to understand reactive constructions. So it's writing a code like which is easily maintainable and easily debuggable. Exactly as we're doing this at home, not home, but in school. But actually, just changing this thread executor is, for us personally, it's like putting an electric engine in a petrol car. That means that petrol cars are built, if we make this association, are built exactly for petrol engines. You have big petrol compartments, you have transmission, etc., etc. That means that you can change it, but you still have old car with the new engine inside. So that's why we have decided to create something that we call Helidon Níma. And it is actually a first ever framework in the world which is fully based on virtual threads only. So it has synchronous paradigms, synchronous way of writing code, synchronous programming model. It has a very good debugger, so it means every debugger that you have right now can debug virtual threads as well. So that means that you don't have to think where and how should I debug it. And as a result, it has a performance which is comparable to that of those of this on NetT. Actually, without too much investing, we will see what is the difference. And if we take a look at the paradigm of the architecture actually of Helidon that we right now, that we just removed this Helidon SE layer and kept only Níma. Yes, you can still use Helidon Reactive on Níma, so that's why I put it there in the corner, but you don't need it. And as in the previous slide I showed you, we have different components which Helidon consists in, well, Helidon Níma. And it also has configuration, tracing, health metrics check, gRPC client server, and of course, WebSocket and web client. That means that you have a set of the same functionality, but now available to you with virtual threads. And you see, we are reusing of the code a lot. So that means that most probably somewhere in the future, Helidon will just go away from NetT just because it is fast. And it has not only fast, but it has quite a big support of everything, like HTTP1, HTTP2 protocol, and MTLS, etc., etc. It allows core static content. It has observability features. And what is cool about it, all of that is built from absolute scratch using the latest Java technology like virtual threads, enhanced switching, sealed classes, system logger, etc., etc. So why on earth would you do this, actually? Why would you stop actually using Helidon SE and switch to Níma? Well, that is why, I would say. This slide says that writing a blocking code is much easier than writing reactive code. And it will really attract more developers to the position that we have right now. So, and as a result, if you run the benchmark, by the way, we have just published our result in Tech Empower benchmark, so they are official. Even with not so much caches, Helidon Níma is now outperforming NetT in quality of request response. And if you saw this layered architecture, it was very easy for us to migrate Helidon MP over Níma, not over Helidon SE. So if we just put a virtual threads with Níma there, you don't change anything. You don't change the code, nothing. You just wait for the code to become really fast. In this case, it's 2 and even more time faster. And this is what we call it. So technically, you have not a petrol car with electric engine, but full new platform, which is specially designed for virtual threads. And this is it. Let us actually see it in our demo. So I will go to our special project I have created for you. So it has, actually there are 5 different projects. So first of all is the clients. So client quick is scanning for endpoint which gives us quick response. Clients call slow scanning for and checking, measuring the information about slow endpoint. As I tell you, these endpoints, how they look pretty easy. So the quick endpoint just returns done, and the slow endpoint slips a little bit and returns. As it slips, it blocks the thread. That means that this thread cannot be used anymore. The very same is done with reactive. You have slow and quick endpoints, so you should just send a response. Yeah, for the slow endpoint, it was very hard to do something in parallel in environment of reactive because it's non-blocking, but still with some executor schedule service, it will do it this way. We have specially limited the endpoint here with only 10 threads, just to show you actually how it works. And if we go to, as I say, we only need to change one option in Helidon to enable virtual threads. So we just said that enable virtual threads true in our Helidon mp-loom sh file, and the other will be make them false. As easy as that. The next thing is that we have the same code written in Helidon Níma, which is cool because it follows the same paradigm, quick and slow, and it's very easy because it's very straightforward. Let us actually run it. I will open a window group. Let us see what happens. So I will start the server without loom, so no loom sh. So it started, and start the clients. Java -jar target. This is client slow. Yes. So Java -jar target clients. Yeah, quick. So what we have right here is that you see the slow client actually gets the requests ready, but the quick client, as all the threads are blocked here, usually gets a lot of errors, so it simply cannot process the result because all the threads are blocked. So now if you see the htop, we will see that the utilization of the processor is really bad because most of the time we're just sleeping and doing nothing actually. So you see, this is not about performance but about throughput. Okay, if we rewrite run it in reactive way, so I will just do Java -jar target reactive. What you will see here, that the slow requests are doing their job, but we still receive a response for the quick. So that's why with this non-blocking way, we find resources for serving all the slow and the quick. This block time is being reused by reactive. So this is what we have right now as a solution. So for example, if you want to write a really performance service, you need to do this reactive. Now, if we just run our previous microprofile example with Loom server, let's see what will happen. So suddenly we see that changing one option in our code enables us to run blocking code and non-blocking code, not blocking, but weak code and slow code all together. That means that we suddenly start reusing our processor much better. You see just from htop, it's just reusing full power, which is like awesome. It's just changing one option. And now if we stop the server and run it with Níma, so I will just see what we have in the target. Yes, server Níma blocking. Yes, we have to enable preview. Yes. Because it's a new feature. Let's do it this way. Yeah. We will see that now we have a fully blocking service which returns us the result we want in fully blocking way, only with JDK. And this is what are we doing right now. So that means that with Helidon Níma, and Project Loom, we are now able to reuse our resources of the processor as much as possible. So that means that once again, we are not enabling better performance. You won't receive suddenly more cores than your processor had, because here we are not solving the obstruction problem. Obstruction being that your thread is blocked all the time. But if you have small tasks which are waiting for resources and which stay blocked, for example, for a file to be open or a database read to be done, um, we are solving this. Previously, we had been solving it with a reactive way, with non-blocking way. But now, as we have virtual threads, we are able to easily block, and JVM handles this for us. We can solve it the same way in the blocking way. So funny thing is that the more we block, the better the application performs. That means if, for example, in Linux we use asynchronous socket, it will be better if we block them. Then the JVM knows better when it's blocked and reuse the resources. The same is for well, the better performance is achieved in blocking sockets. So as we're used to asynchronous code, we now need to unlearn a little bit to start blocking again. As a result, we have much better HTTP performance and we will have much better gRPC performance because we made our own implementation. We do not reuse anything. And once again, we are trying to reuse as much models as possible, like fault tolerance, staticon, etc., etc. But the idea is that it's now the biggest challenge to unlearn to do reactive and start blocking the code again and again. And then you will have much better performance and much readable and debuggable code for writing your application. So we made a small journey together with you from reactive standard, from blocking standard code in microprofile. Then to receive some performance, we needed to make it reactive, but it won't be it was not portable. And now we came back to blocking code with Helidon Níma, and now our standard portable application in terms of microprofile starting performing the same as it was with reactive. So I believe this is really a big game changer, and I really hope that so what I said was useful. So thank you very much. If you need to take a look about more attention, to take a look about Helidon, and we have a bunch of resources in Twitter and LinkedIn, in Medium, and in YouTube and Slack. So I would just want to say that thank you so much for having me here, and I really hope that you liked this video and you will enjoy working with Helidon. So thank you so much. Goodbye.